Yeah, we're going to go ahead and get started. We are delighted that you are here in our open source for public benefit breakout. We have a great list of speakers from various fields and backgrounds that we're really excited to hear about their work. And with that, I will just go ahead and introduce Andy Lyons. Andy is a data scientist and program coordinator for UC Agriculture and Natural Resources, who has spent 15 years developing R packages and Shiny apps for ecological and agricultural applications. He holds a PhD from UC Berkeley and is an experienced data science educator who has taught at UC Berkeley, Stanford, UC A&R, and professional groups in the Bay Area. So please give a warm welcome to Andy.
All right, good afternoon, everybody. Thank you for coming. I'm pleased to talk to you a little bit about some work my group has been doing to develop an open source ecosystem to help build weather-driven agricultural decision support tools, and I'll talk a little bit more about what that means. I'm based here on the Berkeley campus, but I work for the UC Division of Ag and Natural Resources. And if you're not sure, if you're not too familiar with UC A&R, don't worry, you're in good company. But essentially, we are yet another branch of the UC system, the spider web of parts of the UC system. We are a separate division, and we are 100+ years old. We sometimes think of ourselves as the 11th campus because our academics do research and extension, but they mostly do it off campuses throughout the entire state. So these blue dots here are our county offices. We have researchers who live and work in these communities. We also have clusters of faculty with joint appointments on most of the UC campuses, the big five being Davis, Berkeley, Riverside, Merced, and Santa Cruz. These red dots are our network of field stations. I'm sorry, the purple dots, we have 10 field stations. And then this logo farm represents, we have 14 statewide programs and institutes, some of which are public facing, you may have heard of, like 4-H. Others are more niche and research focused. I am with the Informatics and GIS statewide program. We're basically a GIS shop that also supports data science and increasingly web applications for this whole group. So the problem space where we're trying to operate in here is the task of growing food, which I have enjoyed learning about and finding that has many moving parts. So take your humble almond. On the biology side, plants need light, water, nutrients, and heat to grow. And for the fruit to develop, and that's often the part that we eat, the fruit, seeds, or nuts. In addition to that, you're going to need pollination and then some heat or chill requirements for the fruit to develop. On the environment side, the soil provides a lot of these services. So we have to understand soil processes, including how it holds water, the microorganisms, lots of nutrient cycles. Salts can be a problem. And then pests and pathogens are the other big bucket of concerns that affect plants. And they have life cycles, certain pathogens have vectors, and there's population dynamics. So this is the set of natural processes that have to come together to actually grow plants that we can eat. Fortunately, farmers have lots of management tools at their fingertips. So species and cultivars have been developed with different kinds of properties. You can do grafting, planting your crop planting, pruning, irrigation, providing pollinators, beneficial plants, whether that might be cover crops or habitat for beneficial insects, soil amendments, cover crops, reduced tillage, and then a whole bucket of ways to deal with pests, from the more natural ones, beneficial insects, removing their refugia, to targeted spraying. So there's a lot of moving parts here, and all of this has to be done with whatever water is available, which in many parts of the states is groundwater, whatever labor is available, using contractors, because a lot of this is outsourced, to meet the demands of the market when and at the right quality and a very predictable timeline in an extremely regulated environment. and at a profit with major razor thin margins, right? So hats off to any grower who can manage to make this a viable business. Growing food is not easy. That's my first take-home message. Fortunately, agricultural researchers have been working on this for decades, and there's lots and lots of studies that have understood different parts of this process. One small example is the concept of a degree day. This is heat related, but it's not something you would measure on a temperature. It's a metric that represents how much heat the plant has actually been able to use. So within a certain time frame and a certain range of temperatures. And if you do that, and it becomes an extremely good predictor of both plant and nut development and insect development. And there's many others, but I'm just going to focus on this one. But to turn that research and all those hundreds of models that have been developed for the different parts of the system into useful information to the farmer requires some kind of decision support framework, which usually will start with some data, probably some parameters from research, maybe information about the site itself, likely with some weather data, recent weather data. Combine that with a model, which could be a regression model. It could be some sort of formula that generates these metrics. Could be something which is essentially a complicated spreadsheet, lots of small equations and if-then statements, and then provide that to the poor farmer who's really just trying to figure out how she can keep all the balls in the air and get to the end of the season with a productive harvest. So this is well-known territory. In terms of the current landscape of decision support tools, land-grant universities have developed a number of these kind of like online tools that provide the raw data for the information. They tend to be kind of clunky to use. They don't quite get to the last mile of the decision-making process. The ones I know about are definitely not open source. And like a lot of university projects, they have trouble with turnover of PIs and staff and short-term funding cycles. And the end result is they can get stale or broken. Private sector has more resources, more polished interfaces, but they're often bundled with hardware sensors or farm services and tend to be expensive. We know these things can also disappear overnight. And data privacy is a question mark. And with all of these that are not open source, basically you get what you get. There's not a lot of options for customization if there isn't an API that you can play with, or sources to the underlying libraries and data, and very limited scalability because only a handful of people have been working on this. So we had looked into, we've turned to open source and specifically to develop the tools that can help people, help other develop the decision support tools. And the reasons for doing this are probably don't need to explain to this group, but it enables us to reuse some of the back-end components, especially that are a little bit more niche, develop communication and collaboration with other growers or other researchers throughout the country, improve our code, and develop a community. I've settled on R as the development platform, which is a really excellent platform for this kind of work. It's very, very mature. R is developed for working with data. It's widely used in the life sciences among many other fields in academia. It's widely taught. That helps with sustainability challenges. And just the base R plus a dozen or so packages that are widely used provide 95% of the functionality. We don't have to start from scratch. There's API wrappers. There's lots of data wrangling packages out there. There's a really strong community of users. R OpenSci deserves a shout out there. And I want to focus on package development because I think this is a place where R really shines. So what I've worked on is developing a set of R packages. The ones that are highlighted here are the ones that I've written. And these packages do two things. One, they serve a number of these shiny apps, so these R-based lightweight online decision support tools, as well as providing the core functionalities for researchers to keep working with them. So pretty much every project I get on my plate these days, if there isn't an R package already out there, I will put the model into a package as well, and that becomes a product that serves dual purpose and we can keep working with. We also are working with PG Farm. So this is kind of a shared Postgres database system platform that's been developed by the UC Davis Library. And of course, Postgres is a pretty easy to work with. This is a little more detail about the packages that I've developed. Degree Day kind of computes these. There's a few flavors of the metrics, and they're specific to different species that have different sets of parameters. CalAdaptar is an API wrapper to get modeled climate data into our environment without having to download large TIFF files. WeatherDat has been a real game changer. It's basically intended to be a weather API wrapper with a consistent API, because oftentimes you can't just use your national weather forecast for some of these applications. You need more detail than that. Cherry Chill is an example of it computes the chill, which is also another factor that tree crops need to pollinate or to bloom, and that's like fresh out of the oven. So that's an example of rapidly getting the research results into the oven. I'll just go through a couple of examples. So this is a pistachio nut growth calculator. It basically uses temperature only since when the trees bloom, and it provides 3 metrics of nut development. Volume, which basically tells you it's time to harvest. Firmness tells you when they're more susceptible to pest, and there's some pest management implications for that. And embryo length kind of tells you it's big enough now you can turn down the water, save a little money, and it'll still grow pretty well. This is a precision irrigation calculator, not rocket science, but this is an example of a tool which has been really, really localized specifically for the microclimates in Ventura County, the soils in Ventura County, and the irrigation systems. So the PI is a farm advisor down there who works hand in hand with these farmers. And we've come up with a really, really simple user interface because that's what they want, right? So there's like 5 or 6 drop-down boxes. You hit calculate, and it tells you how long you should run your irrigation system. So it's not supposed to be precise, but it gives them a start. And there's a lot of customizations under the hood there. This one is also similar, but it's using climate data, right? So this is one that will tell somebody in the coming decades, because when you plant an orchard, it could be productive for 20, 30 years. Is there going to be enough, are the winters going to be cool enough to have a synchronized bloom and harvest? And then this one has a number of graphs and summaries that are more actionable for someone who's planning their orchard future. To try to build some momentum and to get these tools more widely known out there, I've also developed a GitHub repo with reference data sets so that people who are working in other programming languages can validate their code. That's another challenge, with research computing is we want to support and recognize the contributions of many languages out there, but there's a need to validate code. I've got a code recipes and tutorials for working with these packages across the board, and then I've taught a few workshops over the years. All right, I'm going to skip through. I put together some slides for the coders of you out there. I'm going to go through them, but basically, this is a take-home message that R has done a really, really nice job, in my opinion, at helping researchers and mere mortals like myself kind of publish their code and in a robust way without having a CS background. There's good documentation out there. There's groups like R OpenSci, which provide peer review of code, which I think is another important component of scientific computing, and lots of helpers. These next few slides are going to be some of the packages that help the on-ramp if you're for building packages. I'm going to go through these because there's not time. And just kind of finish up with the conclusion, which are that agriculture is a fantastic, interesting, fascinating system to try to optimize. There's lots of pieces to the puzzle. Open source definitely has a role to play in translating decades and decades of research into useful tools that actually bring public benefit. So if you have students out there looking for projects, or would like to get more engaged in this, please send them my way. Thanks.
Okay, So John Madden is an electrical and computer engineering student at UC Santa Cruz, whose research focuses on low power energy sources and wireless sensor networks. As the maintainer of the open source Environmental Network Sensing, or ENTS project, he specializes in energy harvesting from soil microbial fuel cells and prickly pear cacti, while also supporting the broader ENTS ecosystem. Welcome, John.
Yeah, as the introduction said, I'm going to talk to you guys about the project that I've been working on, ENTS, which stands for Environmental Network Sensing Platform, which is a platform for monitoring environmental data. So what Andy's data is using, like we want to collect that data, other end of it. And today I'm going to talk about our experiences in designing that platform with environmental scientists. So really emphasize on co-design. So quickly, wireless sensor networks, if you're not familiar, is just a generic term for devices in the field that can measure environmental phenomena. Here are just some examples of wireless sensor networks. Hibble is a battery-free device for indoor monitoring of environmental parameters. Eclipse similarly does hyperlocal urban air quality monitoring. The work by Dumer looks at activity tracking for health monitoring. Signpost, which was actually originally made here at Berkeley, looks at smart infrastructure in cities by mounting these sensors on signposts. Similarly, Synergy is another generic platform that can be used to build any number of applications. But let me ask you guys this. Have you guys ever heard or seen any of these platforms in the field? No, not likely. So why is that? Let's take a look at two such examples that have kind of seen success in terms of their sustainability and the amount of use cases that they've seen. First is the Puma project from UC Santa Cruz, which looks at making a wildlife tracker for mountain lions when tracking their GPS data over time. They've been collecting this data since 2008 and actually publish it online on their website. Really cool website for those who are interested. And notably, this team works with the California Department of Fish and Wildlife and also uses the data in their own ecological research. We kind of learned that like these partnerships are really important for the sustainability of a platform and a project as a whole. On the other hand, a more engineering example is this Telos device, which is essentially what you would use to build a wireless sensor network. It has basic communication, compute, storage on it, and can be expandable to any number of applications. This is kind of like the other success story that we've seen, where a platform can be expanded on and can move to the whatever the community wants. So we looking at these platforms, we boiled it down into 3 separate principles that we used in the design of ENTS. First is design for breadth, which is mainly for hardware which means design for breadth is essentially like over provisioning the hardware so you don't need to do hardware modifications down the line, as that's timely and costly and is not as iterative engineering as, say, computer science is. Second is extensibility, and specifically extensibility over modularity. We kind of define modularity as a fixed set of interchangeable parts, but extensibility allows you to add on to existing platforms over time so that they can grow to support a community's needs. The third design principle is co-design and outreach. So actually fostering these community relationships reaching out to community members who would use this platform, actually receiving feedback and using that to guide the direction of development of a platform. So we took these principles into the Environmental Network Sensing Platform, or ENS for short. And I like to emphasize that this platform grew over time. We started off with like very simple logging equipment and has expanded to support a broader community of environmental scientists. The first version of ENS, called Seed or Sapling, looked at studying, was originally designed for ultra low power energy sources. I actually got my start in research studying these things called microbial fuel cells, which you can kind of think of as like dirt batteries in the soil, which produce like very small amounts of power. Therefore, you need specialized logging equipment in order to study these over time. You could get, say, example, like a desktop DAC, that's kind of like the form factor of PC, a multimeter, or this like really basic educational device called a mudwatt, which blinks depending on the power output. None of these really fit the need for what we were trying to do to build, to like collect large amounts of data so that we can analyze it later on. You wouldn't want to put like a desktop, multi-$1,000 desktop piece of equipment in the field where there's rain, heat, and so on. Some other devices you need to go out and check by hand, and so on. So the takeaway from Seed and Sapling is we started, in order to build like a WSN platform, we needed to start by being good at one thing. In that case, that was analog measurement. That way we had a community already formed around the platform that could grow over time. When studying soil microbial fuel cells, I got the opportunity to work with a few environmental scientists. And one thing that I learned from talking about them is that a lot of data collection is done by hand. It's some graduate student going out into the field, taking a hand measurement, putting that in a spreadsheet or some other data format. Me as an engineer think that's crazy. I'm like, if I need to do something multiple times over a long period of time, I'm just going to automate that. So that's where the ENS platform started to grow to. We wanted to enable wireless data collection from sensors in the field and give a visualization platform for these environmental scientists to access the data, basically providing an end-to-end system so that they can focus on their own research goals. Through these experiences, we developed the ENS platform further and worked with a group doing biomimetic leaf wetness sensing for disease detection, where we were able to do such a field deployment, monitoring leaf wetness durations over time. This really emphasized the principle of that extending or extensibility drives the platform longevity. Being able to expand to additional application allows you to grow that community over time and make the platform sustainable. After this, we did further development and got to the current version that we have now with multiple sensor measurement channels, onboard compute, wireless communication, onboard storage, along with permanent backend storage in like a central database somewhere. The ENS node, as we call it, is like about the size of a smartphone and costs around $50. With this version, we collaborated with an environmental science group looking at harvesting energy from prickly pear cacti. And we were actually able to help this group perform or log power over time in the field, which they could not do with their own existing platform. Part of this was making a DIY waterproof enclosure for the field, along with adding, improving our backend so that I can extend to any number of sensors, with power shown at the top and then a soil sensor doing volumetric water content and electrical conductivity below. Working with this group emphasized the takeaway that co-design really guides pragmatic, usable features while avoiding feature creep and speculative engineering effort. These collaborations really drove the development of ENTS over time into the successful platform it is today. I would attribute the main success of ENTS to designing it around open source principles. All our hardware, firmware, backend, and a few other supporting repositories are all open source on our GitHub, which has allowed for a lot of transparency when we go to a group who are interested in using a device. They can see the code, they can know what it does, or they have access to it where they could get someone else within their group to expand upon it. In total, we've had 30 people contribute to the project, from Google Summer of Code, undergraduates at UCSC, other collaborators at universities such as San Diego, Georgia Tech, and so on. So what are we doing in the future to continue the sustainability of ENTS? Right now, we're looking to migrate some of the code base over to, or integrate a larger project into ENTS called Talk, which is an embedded operating system primarily built around security that was originally used in that Signpost platform that I showed earlier, but has kind of fallen off in terms of wireless sensor network usage. One of the reasons why we're doing this is to investigate security in wireless sensor networks, and in addition to supporting additional applications. One of the future applications that we're working on currently with funding from the state of California is working closely with local growers to develop an irrigation system. So here's all the links where you can get in contact with us. We're actively looking for additional applications of the platform and future collaborators. I'd really like to thank all the people who've made this project possible. And you can find a recent publication on the work with the QR code and project repositories up there. Thank you.
Moving right along, we're going to take questions at the end of all the talks. Our next speaker is Tarak Shah, is a data scientist at the Human Rights Data Analysis Group and program manager for the Community Law Enforcement Accountability Network, where he specializes in machine learning and quantitative analysis to human rights and police accountability. He has 7 years of experience working with diverse international organizations and community groups to identify underdocumented violence and racial disparities in big data. One is up and down. Okay, let's all give Tarak a warm welcome.
Thank you. So as you just heard, my name is Tarak Shah, and I'm going to be talking a little bit about a project called the Police Records Access Project, which is a California statewide database of police misconduct and use of force. To start, in order to kind of motivate this work, I want to introduce this concept that's familiar to those of us who work in accountability, which is the idea of the wandering officer, which was popularized in this paper from 2020. But the basic idea is the wandering officer is kind of a colloquial term for police officers who move from department to department, often after committing serious misconduct or serious violence, as a way of evading accountability, but also of kind of continuing these types of practices in other places. And we know a little bit from research in places where the kind of data is available that officers who do have these kinds of histories are more likely to commit those types of acts in the future again. And we also know that like in a much more visceral local way. So for just as one example, I've put up here the career timeline of an officer who at one time was working for the Oakland Police Department named Miguel Masso. While Miguel Masso was working at OPD, he shot and killed an 18-year-old named Alan Bluford. But as you can see from here, by the time he got to that point, he already had a lengthy history of documented misconduct. And so it was stories like this one that motivated our team to work on building this statewide database of police misconduct and use of force in order to be able to track police officers who commit these types of acts. And so the links you see here are to two projects which are pretty closely related. One of them is the National Police Index, or the NPI, which is a nationwide database of police employment histories. So you can actually look up where officers have worked in the past. And the other one is the Police Records Access Project, which, as I mentioned, is a statewide database of police misconduct and use of force. So we're going to take a look at each of them to better understand what they are, and then I'll kind of dig into some technical details. So to start, here is what you'll see if you go to visit the National Police Index. We currently have data, we currently publish employment histories in 24 states. It is a relatively, it's a growing thing, but a relatively new thing to have access to this kind of employment history data. And so here is what it looks like now when you look up Miguel Masso in the National Police Index. And this may look very straightforward and simple, but if you've worked with this kind of stuff before, for many years, the way that you found this out was word of mouth, or if you're really good at records requests. It was not very easy to get this kind of information. If you're paying close attention, you may notice that Masso's New York NYPD history is not part of what you see on this timeline. If that is something that bothers you, I encourage you to visit our page and visit our GitHub page and become a contributor, because we would really like to work on some of these issues. But that's the National Police Index, and so that kind of connects to our wandering officer issue directly, but then kind of what are the stories behind this? You see that, for example, Masso resigned from the Oakland PD in 2014, but what is the backstory there? And so that brings us to the project that I'm going to be talking about, the Police Records Access Project. So this was a project that would not have been possible before the passage of a law called SB 1421 in 2018. So historically, California was one of the most opaque, least transparent states when it came to information about disciplinary histories and other kind of employment data related to police. This changed to some extent by the passage of this bill in 2018 and another bill that was kind of expanded it in 2021. And that made documents related to certain types of police misconduct, sustained findings of misconduct and use of force, public. What this means when something like this gets passed and for documents to become public is not that you can just go on the internet and find them, but that now you can ask an agency for them through a public records request. And if they are obeying the law, they're required to respond, but actually, this is an enormous issue, right? And so as soon as this law was passed, there were lots of efforts across the state for agencies to avoid having to disclose these records that had been secret for such a long time. And so again, this kind of thing, due to records retention laws, these records are being destroyed kind of as soon as possible, in some cases as soon as 2 years after a record has been kind of stopped being part of an active investigation. And so it was really important as soon as this law was passed to start collecting these records before they disappear. And so that's kind of what brought our team together. We're a team of data scientists, journalists, lawyers, and human rights experts. in order to build the Police Records Access Project, which, as I keep saying, a statewide database of disclosable misconduct and use of force under those laws that were passed in 2018. It is a pretty straightforward and simple interface. It is primarily based on search. So the screenshot you see here is me looking for Miguel Masso in the database, just an open-ended search. You can see I have like a handful of case results. And if I click through to those cases, I'm able to search through documents related to that case. And again, kind of centering the search as the interface. And if I click on one of these links to these citations, what that takes me to is something that looks like this, which is an actual source document from an internal investigation. And so the reason I'm pointing this out is like in the way that our database is set up, you're always 1 or 2 clicks away from a primary source document that was actually produced by an agency. This is especially important in legal contexts. So one of our biggest group of users are public defenders who use these databases to investigate officers who have arrested their clients for things like histories of dishonesty and false arrest and so forth. So an incredibly important piece of the accountability story. However, if you're looking at this, remember that our database is a statewide database. In the state of California, there are over 700 different agencies who can hold disclosable records like this that are disclosable under this law. And so what that leaves us with is we have collected over 20 terabytes of unstructured data. This includes scanned PDFs and documents like what you see here. It includes video footage, both surveillance video and body-worn camera. We have many, many terabytes of body-worn camera footage. It includes tens of thousands of photographs that are taken as evidence at scenes of crimes. It includes audio files of interviews with witnesses. And so 20 terabytes of unstructured stuff leads to a large number of engineering and data science problems, which is what I hope to spend the next few minutes talking about. And I've tried to highlight here the kind of key kind of problems that our data science and engineering team tackled over the last year and a half or so. This is also kind of the shape of the open source kind of suite that we're trying to put out one by one, with the goal of we've been talking to people in other states and other jurisdictions who are coming up against similar challenges as we faced as they try to also leverage public records to build out their own kind of accountability databases in their states. So I'll talk a little bit about each of these things. I mentioned we make requests to over 700 agencies every single year. The way most public records requests work, you don't just make a request, get a response, and then you're done. In fact, it's like a series of correspondences. And so every single records request begins a back and forth. We had measured during peak times for us that we were sending and receiving over 200 emails a week in relation to different records requests that were outstanding. And so making those requests, responding to those requests, figuring out if what you got was responsive and was complete or not, all of this stuff is an enormous domain problem, but it's also a huge technical challenge to keep track of everything that's happening. Beyond that, going down, once we get these records, they can come in any format. So some agencies will send all of their records as one giant PDF that's like 15,000 pages. And so even figuring out the boundaries of where a document ends and the next document begins becomes its own kind of technical challenge, right? Clustering is another issue that we ran into. So, the files on our database are organized into cases, like individual investigations that have many kind of steps. They have interviews, they have investigative reports, they have various kinds of notifications and so forth. So there may be dozens of files for each case. But what we get from an agency might be a giant directory of files that are all named 001.pdf, 002.pdf, and so forth. And so figuring out which files actually go together is, again, a really challenging technical issue, and not one that we are alone in facing. It's one that we've heard from other people too. From there, search ranking. So if you use the search on our site, you will find that it's like pretty good at bringing relevant results to the top, which is a non-trivial issue. So just as one example, pepper spray in many jurisdictions is part of the normal kind of all the time gear that a police officer is wearing. And so in many of their incident reports, they will write, I was wearing my full gear, including my gun and my pepper spray. If you search for pepper spray, you're most likely not looking for that. You're most likely looking for a deployment of pepper spray. And you're going to be just flooded with false positives if you just do a raw text search. So actually kind of re-ranking search results is something we spent a lot of time figuring out. Redactions. So agencies are required by law to redact these files before they disclose them. They don't always do a great job. It's a challenging thing, and also they're not very well resourced. But we, as kind of responsible people, very much want to minimize the harm that we do in the process of publishing these huge collections. And so what we've done is design pipelines to try to identify the presence of certain types of sensitive private information. These are things like the names, home addresses, and other information of crime victims and witnesses and so forth. And to flag those so that we don't publish them without kind of further interventions. And then from there, kind of going back to where we started this whole thing, one of the key ways that we want to be able to index and search through this database is by officers. We want to see patterns of officer behavior. We want to see what Miguel Masso did at each of his stops during his career. But you can't do that with a bunch of unstructured data. You can't do that necessarily with raw name searching because people have common names or people refer to themselves in slightly different ways. And so the process of both extracting officer names as well as linking them to their statewide unique identifiers is kind of one of the pieces that brings this whole kind of effort together. So that is like a high level idea of why this was such a challenging technical problem and why we're so interested in making some of these tools available to our peers in other states who are facing the same issues. These issues are increasingly facing everybody in the accountability community, in part because increasing amounts of police departments' kind of activities are electronic. Many more of their reports are either natively electronic or are at least scanned. Most of their records are becoming electronic. And the reason that's so important is in public records law, there is this idea of an undue burden. That is one of the main reasons that an agency can refuse to disclose records. It turns out it's way less burdensome to send you an email with an attachment than it is to go find a file, scan it, and so forth. And so there's much more available, but now we're left with these challenging technical problems. Here are just like a couple of diagrams related to a couple of those problems. So what you see on the far end is kind of the approach that we've settled on to date for our page stream segmentation, that is finding the ends and beginnings of documents within a large file. And what you see over here is a kind of little diagram of how we've been doing file clustering, that is clustering files into incidents or investigations. One thing that's been super important about all of the kind of engineering and software solutions that we've come up with during the course of this project is the importance of integrating human annotation, validation, and verification into the extraction process. And to that end, one of the key kind of pieces that we've had to develop is useful interfaces to do that annotation and verification. Not the greatest screenshot here. I apologize, it's a little small. But the idea here is this is a screenshot from an interface that we use to verify the links of extracted officers to their statewide IDs, which, as you can imagine, was super high risk. Like, that's something we can't get wrong in terms of litigation and stuff like that. So it was important to have human eyes on each of these links, but we needed to be able to do it efficiently because we have so much of this data. We're talking about more than 2 million pages of text. We're talking about, like I said, 20 terabytes of files. And so we found like not small, but like design decisions had a huge difference on both the accuracy and the speed that annotators were able to review things. And so as a part of all of this software, the kind of annotation interface that's used to train and validate these tools is a big part of what we've focused on. So I think I'm about out of time. I'm going to put those links, and if you prefer zines, I have a handful of the zines that we've made for these projects, and you can find me and get them.
All right. On to our final talk for this breakout session. Our next speaker is Robin Riley. Robin is a nonprofit executive and community organizer who consults through her firm Open Chapters on the intersection of social change and open source technology. Her extensive leadership background includes serving as the managing director of the Matrix.org Foundation, commissioner for the Sonoma County Library, and board president and chair of the Open Source Initiative. Thank you very much. I'll hand it over to Robin.
Thank you so much. I am really happy to be here with you all today and sharing a little bit. I will briefly say that I hung up my hat as a developer about 16, 18 years ago. So this presentation is going to take a slightly different form. And I'm also very much a practitioner and not so much in the world of academics. So I've appreciated the style of presenting we've seen. This is a little different and it's going to be a bit lo-fi. So thank you for bearing with me. I want to, again, today talk about communication tools for breaking up with the surveillance state. When I was asked to present in this slot, I thought, public benefit, open source, what do I know about, what feels relevant? And the time that we're living in, this felt like the right thing to speak about. So first, I want to just level set and see where we are at together with some of the core concepts as to like why we would talk about this in the first place. Can I get like a show of hands if you're familiar with like the general idea of what the surveillance state is? Okay. All right. So great, largely familiar, but I'll just unpack it briefly. Folks may remember Snowden or Reality Winner or Chelsea Manning, all these people who have blown the whistle on, particularly in the US, on massive dragnets of surveillance. The National Security Administration, FBI, pick another three-letter agency. We have so many agencies in this country at the federal, state, and sometimes even at the municipal level that are gathering data on us. And we know that this is something that they have done internally. We know that this is something that private interests are getting really excited about too. We see Flock, we see Palantir, we see Clearview AI. That's the surveillance state, right? There's data being gathered about our activities and our movements all the time. Let's talk very briefly. How about surveillance capitalism? Oh, fewer hands. Okay, great. I got to take this fast, but anybody who's using Facebook, anybody who shops with Amazon or Target has like a loyalty card. Do you have a mobile phone? Well, all of these things are accumulating data that are frequently bought by data brokers. And guess who buys from data brokers? Not just advertising people. Those three-letter agencies buy that data too. And suddenly they can correlate this data to develop pretty detailed understandings of who we are and what we do. So in the time that we're living in, especially with rising authoritarianism, it is important to be aware of what we can do to protect ourselves. And so I'm just going to talk briefly about two tools that I'm a huge fan of to help make our communications more secure. There are so many secure messaging tools out there. I'm going to focus on just two. Yes, I'm going to focus on Matrix because that's the nonprofit that I led. I strongly believe in it also. And I'm also going to talk about Signal. Why am I going to talk about these two? Because again, there are so many. Every time I talk about these, somebody's like, well, why not XMPP or Germ or whatever. There are so many out there. Why these? Because both of these tools offer end-to-end encryption. Both of these tools are fundamentally free and open source software. They're mature. They've been around for at least a decade each, which matters. You do not want to be entrusting your security with something that's new. They're both governed by nonprofits. They're both widespread, which means there have been lots of opportunities for things to go wrong, for them to test them in the wild. They're hardened by research. oh my goodness, security researchers love throwing stones at these things, and thank goodness they do, because that helps us dial them in and protect them, protect ourselves even more. These both have different just use cases as well, so I think it's worth talking about them as a set. So Matrix. Matrix is mostly used by institutions. Matrix is a little different than Signal. Matrix is a standard, actually. It's a protocol for communicating. And so there are lots of different clients and servers, but you don't need to worry too much about those details. The key about Matrix is that it is not only decentralized, it's not only federated and secure, but it is also decentralized. And so we see Matrix used frequently by organizations. A lot of nonprofits, particularly in advocacy work, use Matrix. Naturally, a lot of free and open source software projects use Matrix. If they're not using IRC or they aren't using Slack or Teams or whatever, they're using Matrix, particularly in the Linux world. Academic institutions make a lot of use of Matrix, mostly in Europe. There are dozens and dozens of universities in Germany in particular that are using Matrix. Governments use Matrix. France has made Matrix one of the two communication methods that is acceptable for real-time communications within their government from top to bottom. And I should say that Matrix, like Signal, does both text, voice, and video. Well, we got the internet out of militaries, and militaries love decentralized things and secure things as well. So yes, they use Matrix quite frequently. One of the more sympathetic use cases, as far as I'm concerned, are alliances like the United Nations, just recently doubled down on Matrix. Anywho, institutions, large organizations in particular, love using Matrix, and there are lots of small communities there too. Signal is mostly for individual users with some overlap with small communities. I think Signal really has seen anybody here who's been involved with mutual aid or community defense in the wake of the current times we live in. You're probably on dozens of Signal threads. So Signal is what we often see in more individual use cases. And frankly, it is a more drop-in replacement for communications that people are more comfortable with. If somebody hasn't used Slack or Discord or Matrix before, this just feels like texting to them. So it's very approachable, which is great. So I want to talk a little bit about the limitations of these secure messaging tools, because there are very, very real limitations. First, there's going to be a weak link somewhere in your use of these tools. If you're like me, you have made a compromise and you use the default keyboard, software keyboard that comes on your Android phone, or you have your iPhone. Those keyboards are logging all the damn time. In fact, that is partly how they do the predictive text thing. And so this is one way that your data, as you're communicating, even if you're using a secure application or on a secure website, that data can be exposed, because Google and Apple are not necessarily our friends, and they are certainly subject to subpoenas. Notifications. This was in the news recently. Somebody's Signal got popped because their notifications were logged to their messages were logged to the notifications database. And so, for instance, if you're using Signal, configure it so that the contents of your messages are not in the notification. That's a key choice to make. Multi-client setups also increase attack surface. There was a journalist recently who, naturally journalists use Signal quite frequently to communicate with sources. And her Signal account and the information communications in it were compromised. Her phone was fine, but she had Signal desktop installed as well. And that they could access through biometrics. And by the way, if you use biometrics, don't. Law enforcement agencies can compel you to unlock it. Whereas if you've got like a passcode, totally different legal standard. Now here's the bottom line. Here's like kind of the unfortunate thing. I have heard a lot of people, I've heard a lot of paranoia, frankly, in activist and organizing spaces. And I think honestly, it's understandable because the risks are significant. The politics of our time are terrifying. And so we want to do everything we can to protect ourselves. We hear OPSEC has become very popular, and we say, don't take photographs at protests. And in some cases, sure, that makes sense. In other cases, we're really, really going to the extreme of what's reasonable and what makes sense. At the end of the day, we cannot beat the surveillance state as it exists today, but we can protect ourselves. We can limit our risk. The key is that if you really, really want to go to the extremes of security, you're suddenly going to be making trade-offs with user experience and usability. And everyday people are not going to make all those sacrifices. It becomes a pain in the ass. I was consulting with a local nonprofit recently, and we're talking about how to secure their communications because they have a rapid response network. They do community defense and mutual aid and all of these things. And we want them to have the most secure setup they possibly can. And yet at the end of the day, we have to know that if we want to lean too far into security, the people, the volunteers, even the staffers of this nonprofit are just not even going to use that technology. Or if they do use it, they're going to start writing passcodes down on sticky notes or something to make a shortcut so that it is easier for them to use. And so there really is a sweet spot of security and usability, and there are trade-offs in them. And we just need to be cognizant of that. One of the things that I want to highlight here is that as adoption of encrypted messengers goes up, all of our collective risk goes down. So as an example, do I use Signal for secure messaging and sensitive things? Absolutely. But I also use it for planning dates with my husband or sending gifts to my friends. There's so much nonsense in my Signal. It's 97% nonsense. And then 3%, there's advocacy and organizing that's very sensitive. The reason that as adoption goes up, risk goes down is that there's suddenly a volume, a flood of information that becomes more difficult to sift through. Now, yes, this is a cat and mouse game. As our tools to protect ourselves gets more sophisticated, so do the tools to sift through all the data to suss out what's going on, like the development of LLMs. Oh my God, okay. It is easier than ever for them to sift out, find the needle in the haystack. But again, the volume we create, the more voluminous the encrypted data, the safer we all are. So that both goes for your individual use case. Use these things as your default messaging tools because the more nonsense in them, the safer your actual sensitive stuff is. And then get your friends and family to use these things too. We've actually already covered this, but I think it's just really important to drive home. There is no perfect security. There is no way to be completely invulnerable when you're up against a nation state. So the best thing that we can do is make some pragmatic choices, understand what the trade-offs are, and then just commit and do our very best. Because at the end of the day, theoretical security gets us nowhere. The choices we make in our day-to-day lives, the things that we can actually make habits of, those are the things that we can that help us and everybody around us be more secure. So I will briefly wrap up with a few things that I see as improvements that are needed, both for Matrix and Signal. So Matrix has a nonprofit foundation. It's based in the UK, and it has open governance, which is fabulous. It is underfunded, like every other open source foundation, and that's a vulnerability. Signal is got a ton of grant money, benevolent dictators just gave it a ton of money, and they're doing fine. And they've started to monetize the app with backups and things like that, which will help them be sustainable. But at the end of the day, we need to make sure that the things we're relying on have sustainable revenue models so that they're here tomorrow and that they don't have to, say, slack on their security engineers or researchers and suddenly become less secure than they are. So I think the funding is an issue. Governance, I'm actually concerned about Signal governance. There's no open governance there. It's a single nonprofit. They can do whatever the hell they want. Meredith Whitaker is a phenomenal president. I trust the people who are in the leadership there right now. But ultimately, we need an evolution of governance in all of these spaces to be more mature and more reliable. I mean, in a technical sense, the less centralized we can get, frankly, the better. Peer-to-peer communications are a phenomenal direction to go. Mesh networking to get off the mobile networks in the first place, be more resilient when they go down, because not only disasters will bring them down, but sometimes governments will bring them down intentionally. So these are improvements that I hope to see in these tools. We don't see them yet. With that, I will end with a call to action because at the end of the day, I am an activist and not an academic. Please get your organizations and your institutions to use Matrix. Look at the client is called Element. The most popular client is called Element. It's very friendly, easy to use, and get your friends and family to use Signal. I'll just briefly say a little anecdote here. My family was split between iPhones and Android devices, and the fact that when we sent messages to each other or photos to each other via text, some of us were getting really, really crappy photos. That was great motivation to get people over into Signal. And it just feels so familiar. So thank you for your time.
Okay, and let's get all of our speakers up here for our panel and Q&A. Okay, so I really enjoyed those talks. I hope you all did too. We are delighted to have this panel of fantastic speakers and humans here to talk about open source for public benefit. So I'm going to open with my sort of starter question, but by no means an easy question. And then I'll open it up to the audience and you can ask whatever questions you would like of our speakers. So my question is, what would it look like if academia treated open source as a public necessity rather than just a byproduct of research? What would that future look like and how might we get there? And this is for each of you.
Right, I have the least amount of time to think about that, but I see the benefits first. I'm sure there's some trade-offs, but starting off with if the virtues of open source are what we all highlighted, the ability to have nimble products that are transparent, that nurture and cultivate communities along with them, and get more brains around a problem and understanding the solution space. The take home for me for this session and this whole summit is really what was said yesterday, that open source, it's more about the community than the code. So by using code that inherently nurtures community, that's going to be a real benefit for academia. And I'll let my colleagues talk about the trade-offs as well.
Yeah, I have to agree with what Andy said there. It's like very frequent. I'll like read a paper, try to go find their code or whatever, don't find it at all. I feel like if there's more incentive to do that, to like maintain like these open source repositories, then there would be a lot more collaboration between all of them. I guess for like disadvantages, I mean, ideally, it's like funded work, or it's treated as a publication, or there's like some value that you get out of it. But right now, there's not that much right now, which I think is limiting it.
Yeah, too. So I'm also not an academic, and so this isn't like my natural environment. But based on the experience and speaking from my field, I would kind of second what Andy was saying about nurturing community. I think like our work in human rights and accountability is necessarily about being part of a larger community and a larger ecosystem. The work doesn't make any sense if you're doing it kind of for privately for yourself. And importantly, like we have accountability also. Like I talk about accountability for state agents and so forth, but like our work is ultimately accountable to survivors. The reason those laws that I described got passed was because of advocacy of survivors of police killings, primarily, and their supporters. But it's not just like a practical thing. Like it doesn't make sense to do any of this work unless it's for them and for their benefit. And I feel like understanding ourselves as part of an ecosystem or part of a community, as opposed to like a self-contained all-in-one project, is an important way of remaining accountable to what matters. And as I've been learning over the last couple of days, developing software in a particular way can help to cultivate that sense both within your team and in the ways that people relate to your project.
I love what's been shared up here. I think we've seen open source go from something that a few radicals thought was like, well, this is the right way to share what we build, to something that people started to recognize, oh, there's a methodology here, and more of us are collaborating in this way. It's that more powerful. And suddenly businesses started to catch on, like, oh, there's value here. We can actually this is very profitable for us. We can externalize some of our costs, et cetera. I think we're transiting sort of a maturity, a process from which, at the beginning, what is this open source stuff at all, to, hey, now we're really all feeling serious benefits from it. And yet it feels to me like we're at a stage that must have been like the early days of logging, where people are just like, oh, trees, let's cut it down, right? It's extremely extractive, and the power dynamics and the resource disparities are just phenomenally broken in open source right now. And so I'm so happy to see the OSPO network and the UCs, burgeoning, because those are the teams that can help the whole institution come to understand the relationship with open source, this sort of ecosystem and community understanding, and recognize that these are communities to be tended and not just an end product of research, which is extremely valuable for reproducibility and citations, et cetera, but also let's continue to think about impact and maintenance. I guess I'll end the thought there.
Thank you. And does anyone in the audience have a question for our panel?
So I'm particularly interested in the policing project and those records. Have you developed tools as a result of that other people can use? And also, did you use existing tools? Because I imagine looking through unstructured data in the form of PDFs is not a unique problem. And it is for me, doing public records requests, it's a way for an agency essentially to give you the middle finger when they give you, especially if they send you printed documents. It's horrible.
Yeah, agreed. I feel like one of the first public records requests I made, I had like specifically asked, it was from the Berkeley PD, I'd specifically asked for electronic format, and instead they made me come in and get a stack of paper, and they made me pay $2.17 for the copies or whatever, but I paid it all in pennies. Yes, so we're kind of like in an in-between state where some of our tools are public in the sense that the GitHub repositories are public, but not really public in the sense that they're welcoming to contributors. And then there's some that are like still on their way to becoming public, and we have to take out certain types of sensitive data from the test suites and so forth. And yes, it is like an interesting problem where there are a bunch of tools for, and like our kind of the stack is primarily like big open source projects. So all of our code is in Python. We use Postgres and Elasticsearch as our kind of database and indexing backends. We use a project called Arches for maintaining our kind of day-to-day data. And I could go on many different things. And there are certain parts that are extremely not open at the moment right now. So a lot of our data processing was done using commercial LLM models and so like data extraction and stuff. And so even as we work to kind of open source our prompt pipelines, that doesn't really solve the bigger problem there. And so we've been doing a bunch over the last couple of months, actually, to benchmark different open source models to compare as our grant runs out and we run out of free access to Microsoft credits and we actually are forced to figure this stuff out. But it's actually been super revealing because the way that our pipelines are written, the benchmarks are looking better on some of the newer open source models that have come out than the kind of one generation ago commercial model that we used. So that is coming along. We outgrew some of the existing community solutions so Muckrock does a lot, of course, with people who do public records requests, but at our scale, where we were trying to manage ongoing request correspondence with 700 plus different agencies, a lot of the tooling that they provided broke down and actually became counterproductive for us. And so we had to develop our own kind of bespoke solutions, which for a long time was like random spreadsheets and scripts that are on one person's laptop and stuff like that. And so that is part of like when I was like, we are trying to like move to a better open source system is like actually polish those things up and publish them so others can use them. That said, like the problems we have faced, like I think certainly the document processing stuff will be useful to anybody. Some of the stuff about managing stuff at scale is particular to when you're trying to do these like big ambitious public records projects where you're requesting from a lot of agencies.
More questions?
My question is for Andy. So I imagine that the packages that you develop would be very useful for other land grant universities. Have you had interactions? Your colleagues there have tried to grow?
Seen ad hoc come to play. I've definitely gotten a number of requests from people who want to use the R tools that I've put on GitHub. I've tried to make them discoverable. They're also on our universe. I've had a few contributors, but I couldn't say it's gone viral. And one of my goals for the future is to get more linked into counterparts at other universities who are also doing kind of research, either developing these models or developing decision support tools or like policy analyses using these kind of underlying building blocks.
I have a question about the sensor network. I'm curious if all the things you were using were off the shelf or if you were designing things from scratch and the trade-offs you thought about there. I mean, often the trade-off is like it's cheap to get something off the shelf, but maybe it's power hungry or it doesn't have the range you need or something. So how did those kind of factors weigh into the hardware part of?
Yeah, I'd say like 60% of it was designed by us. By like 40% was just use off the shelf components. Just use like it's easy, like there's a reason why like Arduino is so successful because you can just go get components and it's nice and everything. But for yeah, I mean, like, I think one of the reasons why we started to like do more of the design ourselves, which rather than going for more off-the-shelf components, is that we could do like more unique things with it, and actually like make it a little bit more purpose-built for what we're doing for like environmental sensing, and like have less of a barrier of entry to really foster that community.
I have a question for the panel as a whole. Throughout each of these tools, I've noticed like a common thread, like everyone seems to be focusing on ensuring that there's like a that these tools clear like a minimum ease of use, ease of access, ease of usability. Just wonder if each of you might have some comments or thoughts on how you made sure you reached that goal of ease of use, whether that's through some technological tools or in certain ways you interact with your users or other humans in the loop.
Okay, there we go. Yeah, so ease of use, I really appreciate this question, in particular because open source has not always been known for its ease of use, which has been a real barrier to adoption. With respect, I can't speak for Signal, but I can certainly speak, about the experiences I had with Matrix and just sort of consumer applications in general. And first and foremost, when it comes to communication tools, there's something about if what you're shipping is a communication tool, people are going to communicate with you a whole lot. So there's just something about that. We unprompted got a ton of feedback from folks. And so there's the degree to which in open source communities, more and more often we have community managers, right? There's got to be somebody there with a good bedside manner, willing to like take sometimes pointy feedback, and then reflect that into the organization to people who are doing product or design or engineering. But certainly there ought to be actual user studies. The more that we can incorporate that sort of design and research into the development process, the better. It's much harder to shoehorn it in afterwards.
Yeah, I think like you were saying about doing user studies or understanding what people want. I think like you have to do that legwork to be able to build whatever effective system, whether that's like Matrix, like people aren't going to use it, whether it's like you're building it for lawyers, like knowing not to have like 10 clicks to get to the PDF, stuff like that. I think it just really emphasizing the community, emphasizing like the community outreach, like actually putting that effort to reach out and make that. I think that's what makes something successful.
I would concur on usability studies and collecting data from actual users would be the gold standard. That's a challenge because I'm also interested in the potential users who maybe tried it but didn't come back to it for some reason. And that includes both fellow developers, but also the end users of these decision support tools, which is probably the more important metric for myself and my partners, because if people aren't using it, and there's, as you might imagine, there's a lot of decision support tools that aren't being heavily used for one reason or another. Oftentimes because they weren't really co-designed with actual users. One thing I have built into some of my web apps are more detailed metrics than just page views. So kind of see like where people are getting stuck, or like what how they're using the application essentially. Can't really track with any reliability return users because that's hard. But trying to look for trends, and certainly logging things like errors, which have mostly gone away.
Sorry, I needed a minute to think, so I had them skip. But kind of in addition to what everybody else said, we did do a couple of rounds of user studies for the actual kind of public-facing database. There too, though, it is challenging to define who, like as Andy was kind of referring to, who the right users to be studying are. There's such a wide, like I mentioned, public defenders and journalists as being heavy users of our database who have pretty specific information needs. But there was an interest on our project to reaching out beyond kind of these core communities. And it turns out like the things people are trying to do with these tools are just like very different, and sort of understanding that. From the kind of back end like tool building side, a pattern actually kind of going back to the earlier question, that's apparent in like a number of the tools that we built is that like a lot of the kind of data extraction and processing logic is fairly general and can apply to kind of any unstructured collection. And then what kind of makes it good enough is like a sprinkle of domain knowledge in the right places to kind of bump up certain types of performance. And so understanding that pattern and creating ways for domain experts to add that knowledge to the system while being able to benefit from the kind of general purpose part is like strategically a useful thing to be thinking about.
Might add another one, which would be peer review of code. I think would be extraordinarily valuable. And there's groups that are kind of set up for that. So that feels like a community need that we would all benefit from is more and easier ways to kind of share code and get people to look at it from the development side.
If there are no more questions, I have a question. Since we've been talking about the importance of, it's the people, not just the code, and you all have clearly thought a lot about the user experience. That got me thinking about sort of the community and how do you build a community, particularly in projects or domains where there's not a lot of funding? Are there any kind of hacks or tricks where you can help build that cohesion on a limited budget?
Oh, funding is such a sore spot. I think one thing that we've seen over the last 10, I don't know, I lost track of time. But one thing we've seen more of, which I think has been very helpful, is crowdfunding, honestly. Certainly for open hardware, we've seen crowdfunding become a really essential way for folks to get off the ground. Maybe they have the time to build a prototype for themselves, but how do I make this something I can replicate and productize, et cetera. So there's crowdfunding. I think also one thing that I see a lot of hope in for open source. Right now, a lot of the hope for open source writ large. Yes, academic institutions, and I'm so glad that California continues to invest, but the federal government has certainly withdrawn on that front. The European Union has put so much money into open source, and it's still like 1 or 2 orders of magnitude too small and too time bound. But the Horizon Grant Program, the NLNet program, in fact, I'm going to shout out the NLNet program again because you don't have to be in Europe to take advantage of that. And in fact, it's designed for people to apply. You don't necessarily need to be experienced with writing grant proposals. They can be fairly small. It can be just $50,000, but that can make a world of a difference for a lot of projects.
I'd say one way is I think there's a speaker earlier talking about like the open source community as a whole. I think like maybe donating time in terms of like you can help out with one aspect of another project, and that project with their skills can help out with your project. I think that can be one way to get around funding and use like shared resources to help progress projects forward.
Thank you. That's one other thing that I figure actually I should suggest. Frequently, membership programs, or like if you have a few people in your community who believe in what you're doing, if you can set up something where you're getting a small amount of funding every month from them, whatever the platform is, doesn't matter. It may not be that those small dollar donations make the world of a difference. Maybe they give you a little breathing room. Maybe they reduce your infrastructure costs, but they certainly don't pay for your time. The thing that I found most valuable in terms of fundraising, the individual donors, if you look at mature open source foundations, about 10% or less of their revenue comes from their membership programs. But you can start there. And as you build advocates and champions, that's a leading indicator for the institutional support that you get later. Because guess what? Those individuals work at companies. They go to schools. They belong to communities that might be able to rally those resources. So starting at an individual level, might be a way to get started.
There's also one other thing that I remember to add. I know for like the ENS project, Google Summer of Code was actually a really great way to get like contributors to the project that I guess that's funded through Google. But like a similar structure we used for mentoring undergraduates at UC Santa Cruz, where undergraduates wanted, say, their research experience or more technical expertise beyond whatever classes they're taking. We would kind of like teach them on the principles of open source, and they could contribute, and we would kind of like help them through the process. And we would end up getting, let's say, like an issue solved or something like that, and they would actually get like real world experience. So that's been one way that we've gotten around directly, like say, like hiring someone for like a community manager, because we really aren't that big of a project to be able to do that yet.
I took note yesterday, one of the speakers, I can't remember who it was, mentioned at Stanford University, the Invest project. They discovered a lot of consultants were using it in their services, but not giving anything back, which is annoying, but they started inviting the users to their annual meetings to share what they're doing and try to nudge them into becoming contributors and then more meaningful developers. So yeah, just kind of that kind of outreach and maybe going halfway to people who are potential users. And of course, the earlier you can engage them, probably the better the odds.
Yeah, that point about inviting folks to your community meeting reminded me of a developer I knew once who worked on a really kind of contentious data structuring project. And you would think that data structuring could not be an emotional experience, but you'd be wrong. And he once said, you'd be surprised how many problems can be solved over a good meal. So anyway, we'll end it there. And thank you all for attending. And thank you very much to our presenters and panelists. Let's give them a big round of applause.